Scikit-learn tip number 50. Here's a simple pattern that can be adapted to solve many machine learning problems. It has plenty of shortcomings, but can work surprisingly well as is. Okay, before we talk about the shortcomings, let's go through the pattern. At a high level, what I'm going to show you in this tip is a pipeline that you can directly use, or at least adapt, to solve many supervised machine learning problems. This builds on top of what I've covered in a lot of other tips, so I'll mention those tips throughout this video. Let me scroll down so that you can see the pattern. This is a two-step pipeline in which the first step is a column transformer for pre-processing, and the second step is a logistic regression model for classification, though the second step could just as easily be a regression model for a regression problem. Almost all of the code you're seeing is for pre-processing, and the pre-processing code is split between numeric columns and categorical columns, so let's walk through that now. For the numeric columns, we're using simple imputer to handle any missing values. We'll impute the median rather than the default, which is the mean. We'll also set add indicator to true, which adds a missing indicator column to the output matrix and effectively treats missingness itself as a feature. You can learn more about add indicator in tip 9. We'll also set up a standard scaler in order to do feature standardization. This is useful because some machine learning models work best when the features are standardized, meaning they are centered around 0 and have a variance in the same order. For the categorical columns, we'll again use simple imputer to handle missing values, but this time we'll impute a constant string value. As I talked about in tip 27, this is basically like treating missing values as a separate category without having to set add indicator to true. We'll also set up a one-hot encoder to numerically encode these features using a one-hot encoding strategy. We'll set handle unknown to ignore rather than the default of error so that the encoder can handle categories in the new data that weren't seen in the training data. You can learn more about handle unknown in tip 7. So far, all we've done is set up 4 transformer objects. Before we assemble these together, we're going to set up 2 column selector objects. We'll use these objects in the column transformer to automatically select columns by data type so that this pattern can be used with any data set regardless of its column names. The first column selector selects all numeric columns, and the second one selects all non-numeric columns. You can learn more about make column selector in tip 2. Finally, let's assemble all of these pre-processing objects together into a single column transformer using make column transformer, which I covered in tip 1. Make column transformer accepts tuples, in which the first element of the tuple is a transformer, and the second element of the tuple is the columns to which you want to apply that transformer. The first tuple handles all of the numeric columns. The transformer is a pipeline of median imputation and feature standardization, and that transformer will be applied to all numeric columns via the numCols column selector. The second tuple handles all of the categorical columns. The transformer is a pipeline of constant imputation and one-hot encoding, and that transformer will be applied to all non-numeric columns via the catCols column selector. And with that, we've got a single column transformer object that will handle all of our pre-processing. The final step is just to combine the pre-processing object and the logistic regression model into a pipeline using make pipeline. That's the end of this pattern, but I also added some code at the bottom just to demonstrate that the pipeline can be cross-validated and that it can be used to make predictions on new data. Note that I didn't include hyperparameter tuning, but you can learn about how to tune a pipeline in tip 16. Finally, let's talk about the shortcomings of this pattern. so that you don't blindly use this pattern and assume that it will solve all of your machine learning problems perfectly. First, it assumes all columns have proper data types. If you've got a numeric column stored as strings, for example, this pattern will one-hot encode them, which is probably not what you want. It may include irrelevant or improper features. This pattern will use all of your columns as features, even columns that you know are not informative of the target, as well as columns that you are not even allowed to include because they leak information about the target. It does not handle text or date columns well. If you have a text column, you would probably want to use count vectorizer rather than one-hot encoder. If you have a date column, you would probably want to extract relevant features from the date rather than one-hot encoding it. Speaking of extracting features, it does not include feature engineering. Often, your model will benefit from you adding new features that don't natively exist in the dataset. Ordinal encoding may be better. We used one-hot encoding for categorical features, but ordinal encoding is likely better for any ordered features, as I talked about in tip 6, and it may be better for all categorical features if you're using a tree-based model, as I talked about in tip 43. Other imputation strategies may be better. We used simple imputer for missing value imputation, but you will often get better results by using KNN imputer or iterative imputer for numeric features, as I talked about in tip 11. Numeric features may not need scaling. We included a standard scaler in the pattern, but feature standardization is actually unnecessary for many machine learning models. A different model may be better. We only tried one model, namely logistic regression, but another model may work better for your particular data set. And there are probably other shortcomings of this pattern that I forgot to include. The point is that this pattern is a great starting point, but you'll want to carefully adapt it to your particular problem and data set. That's it for this tip. If you want to enroll in my free online course that includes all 50 tips, go to courses.dataschool.io, and there's also a link below. Thanks again for watching.